Okay, going through all this factorial stuff has taken us to about 7.5 minutes. So to speed this along, I'm going to go through these examples up to number 6. And if I feel like something's different, we'll definitely go through it. But other than that, I think these first few examples are much like what you've seen in the past. So let's go ahead and go to number 2. It says, and remember, I used to teach at Newcastle, so these examples are not Decatur friendly, but it says the math club at Newcastle has 12 members. The club must choose a president, a vice president, and a secretary. How many ways can these positions be filled? Here's how we used to do it. This would be the president, the vice president, and the secretary. You can choose from 12 people. You cannot be your own vice president, though, so we have to select somebody different each time, and we would wind up with 1320, and that would be the amount of ways these positions could be filled. If you do the permutation method, you get the same answer. But what I would also like to do when I get back, perhaps, is you can do this in the calculator, and it actually looks like what you see right there, and you don't have to do any calculations at all. So you can still do this by hand if you did the 12 factorial over the 9 factorial. Where am I getting 9? Remember, 12 minus 3 is going to go on the bottom. That would still give you 12, 11, 10, 10, and then the 9s would all cross off with each other without me writing it out. So you get the same answer. Let's move on to number 3. Number 3 says a local band is touring Indiana. The band can visit Indianapolis, Fort Wayne, Bloomington, Columbus, Gary, Elwood, Mishawaka, and West Lafayette. A tour consists of 4 cities to be visited in order. How many possible tour schedules are there? Let's see. We have 4 cities we can visit. And if I counted correctly, there were 8 cities. Let's look again. 1, 2, 3, 4, 5, 6, 7, 8 cities to choose from. And you want a tour that consists of 4 cities to be visited in order. I think it wants to know different cities, obviously. If I start in Indianapolis, I can't go to Indianapolis. So the next city must be different, making my choices smaller, then different again, then different again. Total of 1680 or 1,680 different ways to have a tour of 4 cities. Example 4. How many 3-digit numbers can be formed with the digits 2, 4, 6, 8, and 9? That's 1, 2, 3, 4, 5 different numbers. If each digit is used at most once, how many of these numbers are smaller than 500? Okay, let's answer the first part where it says how many 3-digit numbers can be formed. That would be 5 times 4 times 3, or 60. And again, this would be written in today's formula like this. And if it wanted to know how many of these are smaller than 500, we've seen these before. These are where event blanks sometimes don't work, sometimes do, sometimes we refer back to a tree. This one I'm going to show you we can use event blanks. If you're picking a number smaller than 500, you want to make sure that that number that's out front there is either a 2 or a 4, meaning your number is either in the 200s or the 400s. If we pick a number from this region, we're going to get something in the 600s, the 800s, or the 900s. So there are only 2 choices here, 2 and 4. And then for the remainder, let's see, if I go and I pick 2, let's say, that brings me down to 4 choices, just like it did here. And then 3 choices, just like it did here. Just a reminder, when they talk about these restrictions, a lot of times it's going to be the same math as the total, except for whatever they're asking you to change, which was just our first digit, making sure it was smaller than 5. So we multiply this together and we should get 12, 20, 24 codes are smaller than 500. Okay, let's look at just 2 more examples. A product code is formed by arranging 5 different letters from the collection of BH, QT, WZ, one after another. 1, 2, 3, 4, 5, 6. So it says that there are 5 different letters, but there are 6 here. different choices. Just wanted to note that. It says how many different such codes are there. So for the beginning of this, if I have 5 numbers in my code, and I go with 6, 5, 4, 3, 2, I get a total of 720. So permutation of 6 and 5 is 720. Okay. How many of them contain the letter H? I want you to go ahead and pause this video and see if you can figure that out on your own, and then hit play to see if you did it correctly. Okay, you're probably either continuing the video or you paused it and you want to see if you got it right. Let's see. I'm wondering if you actually wrote a lot or a little, because I can see if you totally wrote a lot. Here's why. Let's say you want to know where the letter H is out of these 5 spots. Let's say H is here. Okay, well that changes and then everything else stays the same. But then where else could H be? H could be here, or here, or here, or here. And so to ensure that I include all the possibilities of where H would be, if you think about it, there's really just 1, 2, 3, 4, 5 different places H could wind up. So you could say or, and then you could put H here, and you could say or, and you could put H here, and you could say or, and you could put H, wherever, 4th, 5th. My point here is that you see the numbers are just going to shuffle. It's the same numbers over and over and over. So rather than doing that, I'm just going to say, okay, well, I have 5 different places that H could wind up with the same numbers. So I'm just going to take that total and multiply it by 5, which is the same as adding it up 5 times. And your answer here would be 600. Lots of them contain the letter H. Okay, last part. Example 6, a debit pin. Many of you probably have or will get a debit card. Consists of selecting 4 distinct digits, 0 from 9. Just a heads up, that is 10 digits if you count them all up, not 9. So the thing here is it says distinct. Right there. So while debit cards could have a code for 1111, not a very creative PIN number, we're going to play by the permutation rules and say that you can't have any repeats. So this would not be 10 times 10 times 10 times 10, but rather 10 times 9 times 8 times 7, or 5040. And then part B, so that's how many codes there are total. How many codes contain the number 7? Well, this is very similar to the one we just talked about, where if we say one of these ways, let's say we pick 7 here, then we could say, okay, well 7 could also be here, it could also be here, it could also be here. That's 4 total ways. So when you multiply this out, you're going to get 2016 codes with the number 7.